So moving right along with the unit, we are on lesson 10-7. We're just going to take a look at a couple of more of these application questions. But before we do so, I want to look at two do now questions. Why don't you pause the video and try these two on your own before I go through them? I think it would be a good idea if you're trying them on your own first. So these two questions have to do with cofunctions. We're dealing with sine and cosine. They're telling us sine of some angle is equal to cosine of some angle. Since these are cofunctions, sine and cosine are cofunctions and they are equal, they're ratios, so this is giving us the ratio of sine and the ratio of cosine of that angle. They're telling us the ratios are equal, and they're equal when their angles, the two angles, add up to 90 degrees. So now we have an equation that we can go ahead and solve. 3x plus 3 equals 90. 3x equals 87. So then x equals, what is that, 29, choice 3. The second one is similar in the fact that it's still dealing with cofunctions, but it's different because they're telling us sine of a, all of sine of a equals 5x. This is the ratio. That's telling us what the ratio is. This is telling us what the ratio is. Whereas A and B are angles. A and B are angles. So these angles, A plus B, has to equal 90 degrees because this is the right triangle. It's a right triangle. Here's C, so here's A and B. A and B have to add to 90 degrees, but their ratios are going to be equal. Their ratios are going to be equal because their angles add to 90 degrees. So we could set up the equation 5x minus 0.2, and that's going to equal 3x plus 1. So let's solve it out. That's 2x equals 1.2. Divide both sides by 2, divide both sides by 2. And x is equal to 0.6. Now in the first one, x is in the angle portion. So x, the variable, is where our angle should be. The variable is where the angle should be. So if the variable is where the angle is, then you're going to add those angles to 90 degrees. Whereas in the second one, the variable was where the ratio should be. So you're going to set the ratios equal to one another. So we'll get into a few more application questions, and these could get a little bit difficult when there's no diagram and you need to kind of analyze it and draw it for yourself. So we have Frida right here. Frida is training to use a radar system, and she detects an airplane flying at a constant speed heading in a straight line to pass directly over her location. She sees the airplane at an angle of elevation of 15 degrees and notes that it is maintaining a constant altitude of 6,250 feet. Then 1 minute later, she sees the airplane at an angle of elevation of 52 degrees. How far has the airplane traveled to the nearest foot? Take a moment and try to draw it for yourself. I know it's difficult, but try it and see if your diagram matches what I have in a moment. Okay, so as I go through this, so here's Frida, move that over here, here's the airplane. So she sees the airplane, which has not passed her yet. It's heading in a straight line, about to pass directly over her location. So she sees the airplane at an angle of elevation of 15 degrees. Let's make a right triangle out of this. Okay, so there we go. And I'm going to go ahead and put in 15 degrees. Okay. Another thing is that it's maintaining a constant altitude of 6,250 feet. So 6,250. So that's the first part. She detects an airplane at an angle of elevation of 15 degrees, and the altitude is 6,250 feet. 1 minute later, so a minute later, this airplane's flying on at a straight line. So maybe here's 1 minute later. She detects the airplane at an angle of elevation of 52 degrees. So now this whole big angle right here, this angle right here would be 52 degrees. And again, the altitude is 6250, so this is also 6250. So we have two right triangles going on here. We want to know how far the airplane has traveled to the nearest foot. So we want to try to find this distance. So let's think about this. We have two right triangles. We can get all of our angles if we want to. So if we almost kind of separate this. So let's just delete that. Okay, so we have a right triangle here. So 15 degrees, I could move over there. Okay, sorry. Okay, and we have another right angle over here. Let me just go ahead and do that. Okay, so let's just fill in now that I've separated these. And I think the hardest part is drawing that diagram. It definitely is difficult to kind of figure out, but kind of need to go through it carefully and see if it makes sense. So both of these would be 6250, 6250. Now we want to find how far the plane has traveled, so we want this distance, here to here. So what we can do is figure out this length, call that x, then figure out this length, I'll call that y, and then we'll just subtract the two. What's nice about this is that these are both right triangles, so we could just use our regular old SOHCAHTOA. If you like using the law of sines, by all means you can use law of sines, but we don't have to. We could just use SOHCAHTOA. So we're going to have to do this 2 times. One for this triangle, and subtract the distances. So for our first triangle, we're looking from the perspective of this 15-degree angle. We have opposite and adjacent, so that's tangent. So I could say tan of 15 degrees equals opposite over adjacent. Put this over 1 and cross multiply. And we need to divide both sides by tan of 15. And now we head over to the calculator. Okay, so alpha y equals numerator denominator, and let's go ahead and substitute that in. 6250 divided by tan of 15 degrees. So I want to make sure I'm in degree mode. I am, yep. Okay, and then hit enter. So 23,325 feet. Okay, so let's just write that out. So 23325.317 dot dot dot. We need to do that a second time. Let me choose a different color here. Choose a little orange. we have to do that a second time, but this time for this triangle. It's going to be the same thing, tangent, opposite, and adjacent. So we have tan this time of 52 degrees equals opposite over adjacent. Put this over 1, cross multiply. Divide both sides by tan of 52. Okay, we'll go back over to the calculator. Okay, alpha y equals 6250 divided by tan of 52 degrees. Okay, so you get 4,883. And then again, at the very end, we're going to have to subtract these two, right? Because if we just kind of take a look here, we found this entire thing from here to here was about 23,000. Then here to here was that 4,800 that we just found. So we're going to have to subtract. So I'll do that now. So it's this minus this. Okay. All right, so let's go ahead and write that out. Okay. So this one was 4883.03 dot 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 dot. And then we said we're going to have to subtract the two numbers. So I'll write that over here. So it's going to be 23,325.317 dot 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 minus 4,883.03 dot 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 to give us this length here, the distance the airplane traveled. And we want to round to the nearest foot. So to the nearest foot is 18,442 feet. So that's part one. There's an additional question to this. Determine and state the speed of the airplane to the nearest mile per hour. To the nearest mile per hour. So we're not in the correct units right now. We want to be in the nearest mile per hour. Right now, we're in feet, and we have to think about how long it took this plane to travel. How long it took the plane to travel from here to here. If we go back up, it tells us that to travel in that straight line, it started here, then it says 1 minute later. So I can kind of go back and see that it says 1 minute later. So it took, the plane traveled about 18,000 feet in 1 minute. So every minute it travels about that much. So I could say, right now we're in feet per minute. I'm going to go back down here. And we have 18,442 feet were traveled every 1 minute. Okay, that's a problem because we need to be in miles per hour. We're in feet per minute. So we did this in the very beginning of the year, like unit 1, where we kind of converted. So the easiest thing is probably to convert to hours. So we need it to be miles per hour. We need to cross out, we need to eliminate these minute units. So to eliminate the minute units, we know 60 minutes equals 1 hour. That's our equation, our conversion here. So I need the minutes to cross out. So I'm going to put the minutes in the numerator, and I'm going to put the hours in the denominator. 60 minutes over 1 hour, those are equivalent measurements. We're really multiplying by 1. Now for our conversion for feet to miles, you might not know that offhand, and I don't expect you do. Some of you might. You do get a reference sheet. So I'm going to go pull up the New York State reference sheet for the regions so we could take a look. So here's the reference sheet with all of our conversions. So you would get this on the Regents exam with all of our conversions. We're looking up top here. I'm going to go ahead and just bring that into here. Okay, so we could see which conversion we want. We want the conversion to convert feet over to miles. We want the conversion to convert feet over to miles. So I'm looking here, and this is the one we want. So we need to go ahead and multiply, and we want our units of feet to cross out. So I'm going to multiply by. I need the units for feet to cross out, so I need one in the numerator and one in the denominator. So feet need to go down here. And the conversion is 5280, and that equals 1 mile. So the reason why we have it like this is we need a numerator and denominator to cross out the units. Minutes, minutes cross out, feet, feet cross out, and then that just leaves us with miles per hour. So the last thing we need to do is just multiply straight across. So we want to multiply straight across. So 18,442 times 60, 60 times 1 minute times 1 hour times 5280. Okay, so let's go ahead and take a moment and do that, multiplying straight across. Okay. So 18442. At this point, we'll use our rounded answer times 60. So that's the numerator. So the numerator is multiplying 18,442 times 60 is 1106520 miles divided by 5280 hours. So now we need to divide this because we want it to just become per hour, per 1 hour. So we'll go ahead and use our calculator, divide by 5280. And when we divide that, we're going to get 209.5681 ... They say to the nearest mile per hour, so 210 miles every 1 hour. You could certainly write it like this, 210 miles per hour. So that was a pretty challenging question because we had a lot of things going on. We had to draw the diagram for ourselves, and then we had to do some conversions at the end. We're just going to take a look at one more. Okay, so another similar one where we have to really draw our own diagram here. Okay, I want you to take a moment and draw it for yourself. See if you can finally get one of these. So your diagram should look something like this. We have Mark is on top of here, on top of a 500-foot cliff, and he sees a sailboat at an angle of depression of 7 degrees. So technically, really, your angle of depression is right here. Mark is really looking down here at 7 degrees, but the 7 is then going to eventually go over here because we have parallel lines, transversal, so 7 would go there, but that is technically your angle of depression. And then 3 minutes later, he sees the sailboat at an angle of depression of 32. So again, this would technically be your angle of depression of 32, but it's going to wind up being there. How far has the boat traveled to the nearest foot? So we want to solve right here. Okay, pause the video and get all of your angles, and maybe try this one. Try to solve it out on your own. So after finding all the angles, pairing off sides, realizing that we're kind of working with two triangles here, I'll walk through this. So hopefully you're okay with finding all the angles. We've done that a couple times already. So then looking at this, I'm working in the pink triangle first just because that's the one that has some information, that has an actual side. I want to find this shared side right here, this reflexive side. I'm going to use, you could either use law of sines or you could do SOHCAHTOA. Since this is a right triangle, I went ahead and did law of sines. And when I did that, I found the hypotenuse to be about 943.5. Then I went ahead and worked in the blue triangle. And I went ahead and found this x here. I had to use the law of sines here because this was not a right triangle. So pairing off my sides and angles, I was able to set up the law of sines, and I found the distance the boat traveled, or the sailboat traveled, was 3,272 feet. So now there is a second part to this. So it says determine and state the speed of the sailboat to the nearest tenth of a mile per hour. So we need to ask ourselves, how long did it take the boat to travel from here to here? It says it took 3 minutes. So right now I'm looking at 3,272 feet every 3 minutes. So our speed right now is 3,272 feet every 3 minutes. But we want to convert it over to miles per hour. So the conversion for hours, well, that'll be the easier one. 60 minutes. And there's 60 minutes in 1 hour. And again, I'm doing it like that so I can cross out these units. And now we're in hours. But now we also want to be in miles. So we're going to multiply by, if we go back to that reference sheet. So if we go back to that reference sheet, we're looking at this one right here. 1 mile is 5,280 feet. So I want the units of feet to cross out. So I'm going to put 5,280 feet down here, and that's equivalent to 1 mile. Again, that will allow us to cross out these units, and we're left with just miles per hour. So we're going to go ahead and multiply straight across. So multiply, 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 multiply. We'll see what we get. We multiply our numerators together. So do that on the side here. 3,272 times 60. So if you want to kind of see what I'm putting in. Okay, so that's the numerator. And the denominator is 3 times 1 times 5,280. So that's the denominator. Okay. So we have 196320 over 15840. So we're looking for speed here, miles over hours. We're going to have to divide those two numbers. When we divide those two numbers, we get about to the nearest tenth of a mile per hour, so that's approximately 12.39 dot 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 dot. To the nearest tenth would be 12.4 miles per hour, or you could write mph is fine. Okay, you have one question to do. I'd like you to do this one as your classwork assignment. They do take a while, so I'm only going to have you do this one here. So submit this question. If you want to submit all the notes, that's fine. You only need to submit this one. Okay, all right, have a good one.